Wavetronix is a company dedicated to revolutionizing traffic management and safety through the use of advanced radar technology. Their systems are built to detect vehicles, measure speed, and analyze traffic patterns in real time. Unlike traditional traffic monitoring systems, such as inductive loop sensors or basic camera setups, Wavetronix's radar-based solutions provide precise and reliable data regardless of weather, light conditions, or other environmental factors. This consistent accuracy makes Wavetronix ideal for complex traffic management applications, including speed enforcement at intersections, where they can actively contribute to reducing the risks associated with speeding and red light running. At the core of Wavetronix's technology are its key products: the Smart Sensor HD, Smart Sensor Matrix, and Smart Sensor Advance. Each of these devices has a specific role in traffic monitoring, ranging from high-precision lane detection to proactive speed management. The Smart Sensor HD, for instance, is designed to monitor roadways and highways, providing real-time data on vehicle speed, traffic flow, and congestion levels across multiple lanes. It can identify each vehicle's speed and position relative to others in its lane, allowing it to detect speeding cars accurately. The Smart Sensor Matrix is optimized for lane-by-lane detection at intersections, helping to prevent collisions by identifying potential red light runners and timing signals accordingly. The Smart Sensor Advance is uniquely suited to detect vehicles approaching intersections and measure their speed well before they reach the stop line. This sensor is particularly valuable for applications focused on speed control and safety at intersections, as it allows traffic systems to adjust signal timing based on vehicle behavior in real time. For example, if a vehicle is detected traveling at an unsafe speed, the system can keep the light red a bit longer, effectively enforcing a minor delay that discourages the driver from continuing through the intersection at a dangerous speed. This small adjustment to red light timing is often enough to prevent high-speed vehicles from entering intersections at risky speeds, lowering the chances of accidents. How the system works in practice. Wavetronix sensors are typically mounted at a strategic distance before intersections. When a vehicle approaches the intersection, the radar sensors collect data on its speed and movement using advanced algorithms to assess the likelihood of speeding or running a red light. If the sensor detects that a vehicle is approaching too quickly, it communicates with the traffic signal controller. This controller then adjusts the timing of the light, extending the red light phase to force the speeding vehicle to stop. The goal of this system is to reduce the number of high-speed entries into intersections, where collisions are often more severe due to the speed of impact. These extended red light phases create a deterrent for speeding, especially for repeat offenders who may be accustomed to running lights. By adding a minor delay, the system subtly encourages drivers to slow down as they approach intersections, ultimately leading to more compliant driving behaviors and safer intersections. Additionally, these radar-based systems provide a non-intrusive way of controlling traffic without relying on aggressive enforcement tactics like cameras or fines, which can often generate public pushback. Instead, they work passively to modify driver behavior, reducing the risk of accidents without the need for punitive measures. Safety and traffic flow benefits. The main advantage of using Wavetronix's red light extension for speeders is the enhanced safety at intersections. Intersections are often the site of severe accidents, particularly when drivers enter them at high speeds. By automatically adjusting red light timing in response to speeding vehicles, Wavetronix's technology reduces the chances of these types of accidents occurring. In cities with high pedestrian traffic, this feature is particularly valuable as it offers an additional layer of protection for people crossing the street. Pedestrians are especially vulnerable at intersections, and preventing speeding vehicles from entering crosswalks at unsafe speeds can significantly reduce pedestrian injuries and fatalities. Data from various implementations of Wavetronix technology indicate a measurable reduction in intersection-related accidents where radar-based red light extension has been applied. This is because the system not only controls traffic, but also influences driver behavior, making speeding at intersections less attractive and more inconvenient. Additionally, by promoting safer driving practices, these systems help maintain smoother traffic flows. In the absence of frequent accidents and dangerous maneuvers, intersections experience less congestion and reduced delays, benefiting all road users. Integration with adaptive signal control. Traditional traffic signal systems rely on preset schedules and general traffic patterns to determine signal timing. While this method can manage traffic flow under predictable conditions, it lacks flexibility and fails to respond to real-time traffic conditions, particularly with regard to speed enforcement. Adaptive signal control, which Wavetronix supports, represents a major improvement in traffic management. Adaptive systems use real-time data from sensors like those provided by Wavetronix to adjust signal timing dynamically based on current traffic conditions. When speeding is detected, the adaptive system can make immediate adjustments, such as extending a red light to prevent a speeding vehicle from entering the intersection. Unlike fixed signal timing, which may inadvertently reward speeding by reducing wait times for aggressive drivers, adaptive timing discourages speeding by adding a subtle delay for non-compliant drivers. This approach not only promotes safer driving, but also aligns with broader traffic management goals by creating a balanced, responsive system that adapts to the needs of all road users. Challenges and considerations. While the benefits of Wavetronix technology are significant, there are also challenges and limitations to consider. One of the primary challenges is the need for infrastructure investment. Installing radar-based systems like those from Wavetronix requires a substantial initial cost for the sensors, controllers, and integration with existing traffic management systems. Additionally, these systems require regular maintenance and calibration to ensure they continue functioning correctly, especially in areas with heavy vehicle traffic or adverse weather conditions. Environmental factors, though generally well managed by radar technology, can still pose occasional issues. For instance, heavy rain or dense fog can reduce the effectiveness of radar detection, though Wavetronix sensors are designed to mitigate these effects to a large extent. Public perception can also be a challenge, as some drivers may view these systems as overly invasive or feel that automated speed enforcement is a form of unwelcome surveillance. Addressing these concerns requires clear communication from municipalities about the safety benefits and non-punitive nature of Wavetronix systems, future potential with AI and machine learning. Wavetronix's radar systems are already highly advanced, but the integration of artificial intelligence and machine learning could further elevate their capabilities. By combining AI algorithms with radar data, future traffic management systems could predict traffic patterns more accurately and make preemptive adjustments to signal timing. This would go beyond reactive adjustments to speeding vehicles and encompass a proactive approach, where traffic signals optimize themselves based on historical data, current conditions, and predictive insights. Machine learning could also help identify specific trends in driver behavior, such as times of day when speeding is most common, and adjust signal timing accordingly to prevent anticipated speeding patterns. In addition, AI-driven systems could manage entire networks of intersections in a city, optimizing traffic flow across larger areas rather than focusing on individual intersections alone. For example, if a speeding vehicle is detected in one part of the city, the AI system could adjust signals at nearby intersections to accommodate anticipated traffic movements and prevent cascading delays. This holistic approach to traffic management holds great potential for reducing congestion, improving safety, and maximizing the efficiency of urban transportation networks. Wavetronix's radar-based traffic management solutions represent a cutting-edge approach to intersection safety and traffic flow optimization. By detecting speeding vehicles and extending red light durations for non-compliant drivers, these systems encourage safer driving behaviors and reduce the likelihood of high-speed intersection accidents. While the technology requires investment in infrastructure, its benefits for pedestrian safety, accident reduction, and traffic efficiency make it a valuable asset for modern cities. The ability to integrate with adaptive signal control systems makes Wavetronix particularly versatile, and the potential for AI-driven improvements suggests that these systems could become even more effective in the coming years. As cities continue to invest in smart infrastructure, Wavetronix technology offers a proactive, data-driven solution to the complex challenges of urban traffic management, ensuring safer roads and a smoother driving experience for all.